This is homework set number 8 on formulas, and we're going to look at questions 1 through 5. Question 1 asks us to use this formula here, P equals 2L plus 2W, to find the length of a rectangular lot if the width is 65 feet and the perimeter is 320 feet. Now I'm going to write the formula right here. It's P equals 2L plus 2W, and what it means is in a rectangle, the perimeter of the rectangle, that's the length around, is twice the length, right, because you have two lengths, plus twice the width, because you have two widths. Now notice in this equation right here, there's three variables, three unknowns. I've got the perimeter, that's one. I've got the length, that's the second one. I've got the width, that's the third one. So there's three unknowns, and according to the instructions, we know two of those. We know W, all right, we know that W is 65 feet, and we know P is equal to 320 feet. So I've got three variables, and I know two of them, so chances are I can find the third. So let's just substitute. We'll get P, which is 320 feet. That's equal to 2 times L. Now, L we don't know, plus 2 times W, but that's 65 feet. Let's simplify. 320 feet is equal to 2L plus, now 2 times 65 is 130. I forgot the 1 there, 130 feet. And we're trying to solve for L. So why don't we disconnect the 130 first by subtraction, right? So I'm going to subtract 130 feet. So do that over here on both sides. I'll do it on the left side. So I'll take 320 minus 130. 320 minus 130 is 190 feet, and that's 2 times L. Now we can get L if we just divide by that 2. So 2, well, I'll write it here. 190 divided by 2, 190 feet divided by 2 is equal to L. So that'll give us 95 feet is equal to L. All right, now they're asking us for the length, so I'm going to write this. I'm not just going to leave it L equals 95 feet. I'm going to say the length is 95 feet. I'll answer the question. The question says, find the length. So I'm not going to leave it as L. I guess I could, but this I think is better. They're asking me what is the length. I'll tell you what the length is. It's 95 feet. Now I put the units on here as I went through. You see what I did? I put feet everywhere. Okay, I'm just in the habit of doing this. You don't have to. If you just write it without the feet, you end up with L. You end up with this down here at the bottom. 95 equals L. So that's fine. You just have to remember that the unit is actually feet. The answer is not just 95. The answer is 95 feet. Question 2 asks us to solve this equation here for the specified variable. So I've got H equals VT plus 16T squared. I want to solve it for V. Now, if you recognize this, great. If you don't, it just says this. The height of an object, if you throw an object from, say, the ground, the height of that object depends on its velocity and the time that it's in the air. This is the initial velocity. That's the velocity you throw it with. So I want to solve it for V. So I want that V by itself. So I have to eliminate the T and the 16T squared. Now the 16T squared is being added. So let's just subtract. We'll start there. I'll subtract it. So if I subtract it from both sides, subtract from this side, I can't really subtract 16T squared from an H, but I can indicate it, and it'll look like this. H, and then I'll indicate what I'm doing. H minus 16T squared, that's equal to VT. And now I can get V by itself, if I just divide by T. T is multiplying V, undo the multiplication with a division. So I'm going to divide. So a couple ways to do this now. I could divide the entire side, getting H minus 16T squared all over T, Or I could divide every individual part, every individual term. So I could get h over t minus 16t squared over t. That's equal to v. Oh, I forgot to equal v over here. All right, now this is fine. Perfectly good. But if you do it this way over here, perfectly good too. But if I do it this way, here's what I see. I have a t squared on the top and a t on the bottom. That I have two t's on the top divided by a t down here. One of these t's are going to cancel. Now, we haven't actually gotten to this point yet in our discussion of our algebra. So if you don't know how to do that, that's fine. We'll get to it. But if I did that, I would get this. H over t minus 16t. Oh, I can write that better. Let me just write it better. Minus 16t. That's equal to v. So either one works. You know, and I have a feeling that the textbook wants us to use this one. But both of them work. Question 3, I think this is going to go pretty quickly. They're asking us to solve this equation here for x. Now I've got x plus 3y is equal to negative 3. So the 3y is being added to the x. Why don't we just subtract this? So just subtract that. So I'll get x equals, how about negative 3, and then subtract that 3y. So there we go. I can write it like that. Or if you like, you could write it like this. Well, let me write my negative 3y minus 3. Either way works. All right, now here in equation 4, or question 4, we want to solve this equation, 7x plus 3y equals 21. We want to solve it for y. So here's y. I want to isolate that. So I see that 3 is multiplying it, but the 7x is being added. So why don't we start here, and we will start by subtracting this 7x. So if I subtract it from the left side, it's gone, and I'll get 3y is equal to negative 7x plus 21. And now there's two ways of doing this. I think what I'm going to do is just one way, and that's I'm going to divide every single term by 3. So if I divide every single term by 3, I will get that y is equal to negative 7x over 3 plus 21 over 3, but I'm going to rewrite it like this. Y is equal to negative 7 thirds x plus 7. Question 5. We've got a formula here, right here, x over 3 minus y over 2 equals 1, and we want to solve it for y. So here's y. Now, first up, you can't help but see you've got fractions, so let's eliminate the fractions. We'll do it just as we did in a previous section. I'm going to find the LCD. So the LCD here, now the LCD is this. What is the least common denominator? That is, what is the smallest number that these two numbers divide into? So what do you think the smallest number that 3 and 2 both divide into? It's 6. Now here's how I always get it. Look for the bigger denominator. Now, then ask yourself this. Does 2 go into 3? No. So double this. If that works, great. If it doesn't work, triple it, quadruple it. Keep going until you get this number dividing into this. Now, 2 does not go into 3, so I double this. 6. Does 2 go into 6? Yes. So I've got it. So the LCD here is 6. Now, multiply both sides of this equation by 6. But as we've seen before, what that amounts to is this. If you multiply both sides of the equation by 6, the 6 ends up right here, here, and here. The LCD will end up alongside every original term. So you get the LCD, and then write the LCD right in front or alongside each term. 6 times x over 3 minus 6 times y over 2 equals 6 times 1. And now on the left side, 3 will go into 6 twice, and I'm left with 2 times x, how about 2x, minus, now over here, I get 2 into 6 is 3, so now I have 3 times y, or just 3y, equals 6 times 1 is 6. Now we're close. I want to get this y by itself. So why don't we subtract 2x? Right, so the plan is to subtract that 2x. I'll get negative 3y equals negative 2x plus 6. And now I got a multiplication. Let's divide. So I'm dividing everything by negative 3. So I'll get y is equal to negative 2 over negative 3x plus 6 over negative 3. So how about y equals, now in that first term, negative over negative, positive. So I'll get 2/3 x. Now, over here, plus what? 6 divided by negative 3 is negative 2. So I'm just going to write the negative 2 out there. And there we have it. And that wraps up our questions 1 through 5 in homework section 8.